And in this lecture, we'll talk a little bit, we'll show a small example of how a human can interact with the Raspberry Pi through the tkinter library. So somebody can write a Python program that uses that library and allows the user to have direct control over something hardware, some aspect of the hardware, through these widgets and library components that appear on the screen. So here's our small example using a scale widget. So a scale widget is basically that slider that you see right there. It's called a scale in tkinter. So our program to generate that, we start off with this from tkinter import star, so we import. Master equals tk, so that's creating the master window, right, or the root window, whatever you want to call it. So we create that, and then we create the scale. So w equals scale. We call this function scale, and it generates a scale. And it returns w, which is the scale, the object that represents that scale. Now, scale in this case takes several arguments. Some of them are required, some of them are not. So master, this is the first argument. The first argument is actually the name of the root window, which is master in our case. So you've got to pass it that argument. And then from underscore 0 to 100, that gives you the range of the scale. So every scale has to have a range of numbers. So every these scales, they all have an integer inside, or not necessarily an integer, but in our case an integer. They have a value, a numerical value inside there associated with how far the scale has been moved to the left or the right. So that value has to have a range from something to something. So that's what those two arguments are, from 0 to 100. So this scale, it starts at 0. If you moved it all the way to the right, it would go to 100. And you have to give it some kind of a range. Now then the next argument, which is optional, is the orientation. It says orient equals horizontal. We've made a horizontal scale here. If you didn't give it that, I think the default is actually vertical, so it could do a vertical up-down scale. But either way, you can give it an orientation if you want to. So that call to scale, it returns this scale object, which is assigned to w. So w is now a scale. And then to make that appear on the screen, we have to say w.pack, and then it appears on the screen, and you see something like, depending on what you're using, you see something that looks like the picture on the screen, that scale. Now this draws the scale widget, and the user can now move it. The user can take their mouse and grab on the widget, grab on the slider, and slide it to the left and the right. Now that's part of our GUI. But that doesn't do anything particularly interesting yet. I mean, it's pretty. It draws a scale, and you can move it left or right. But now we want to interact with something with that, right? We want to allow the user to use that scale to control something. So let's say that we want the user, let's say we have some pulse width modulated signal, okay? We talked about in the previous lecture how to make a pulse width modulated signal on a pin. So say we've got that. And we want the pulse width to change, to be controlled by the user through the scale. So our scale was from 0 to 100, right? So let's say the duty cycle was that value. And if the scale is moved all the way to the left, it's at 0, then the duty cycle is 0, which means it's low all the time, this pulse PWM signal. And they move it all the way to the right, it's 100, so it's high all the time. And they can move it in between, 50, and it's high half the time, low half the time, and so on. So we want to make something with a pulse width. We have a pulse width modulated signal. The pulse width is controlled by that scale, so by the user through this scale. So how do we do this? So first thing, we'd have to change our original program a little bit. So remember that line of code where we said w equals scale? We call that function scale, right? So now we're changing that call. The first four arguments are the same, right? Master, the root window, the from and to, the range 0 to 100, orient, horizontal, make it horizontal orientation. But we're adding this command equals update. So what that is, that's what's called a reference to a callback function. Now, the callback function in this case is called update. What that means is that any time a user actually moves that slider, it calls this update function. And what it does is it passes an argument to that update function. It passes a single argument, the number inside that's associated with this scale. So this scale goes from 0 to 100, right? So that number, 0 to 100, according to whatever the scale is on, that is passed as an argument to the update function. Now this update function, you might ask, well, what is this update function? This update function is whatever you want it to be. So you now have to write this update function. So you can see we've written a definition of an update function. Def update duty, it takes an argument, right? Remember I said that this update function has to take one argument, the value from 0 to 100 that the scale is containing, right? So it takes that as an argument, and we just, inside there we call pwm.change duty cycle float duty, right? We just change the duty cycle, we make duty into a float, and then we pass that to change duty cycle. So now, whatever that scale value is, whatever the new scale value is, because this update function, it only gets called if somebody moved that scale. So if they move that scale and they set the scale now at 25, then a duty will equal 25 when you make that call, and you'll change the duty cycle to 25. And then if they take that scale and move to 50, update will get called again, duty will be 50, you change the duty cycle to 50. So in this way, by adding that command equals update, we've added what's called a callback function, right? A reference to a callback function. It's basically a callback function is a generic term. It means a function that is called when an event happens, okay? And it's often used with graphic user interfaces. So update's our callback function. We have to define it. And note, we don't have to call that function update. We chose to call it update. We could have used any name we wanted to, okay? In this case, we use update. So, and we can define that update function and do whatever we want. In this case, it's changing pulse width modulation, but you could be changing, I don't know, whatever you want. So, yeah, the slider takes the argument, the function takes the slider value as an argument, and that's a way you can get interaction to work. Thank you.